The remaining problems in this section all have to do with divisibility, and we start with this one, which says prove or disprove the following. Let n be an integer. If n is equal to 4k plus 1, does 8 have to divide n squared minus 1? So if you think it's a yes, prove it. If you think it's a no, give me the counterexample. Remember, this is an example of a universal because it's saying n could be any integer. So let's give it a shot. Let's see if we can find an n that looks like 4k plus 1. So for example, 9. This is perfect because 9 is 4 times 2 plus 1. What happens when I square the n, then subtract 1? Well, 9 squared minus 1 is going to be 81 minus 1, which is 80 at the end. Is it true that 8 divides 80? The answer is yes. Now, is this a proof? No, this is just a quick way for me to verify that this statement is probably most likely going to be true. And now I'm going to attempt to prove the statement. To prove that this statement is true, let's take a look at the proof, which starts as follows. First, we begin by writing the word proof to indicate where the proof starts, and we're going to pick an integer n that has the property that it's 4k plus 1. Keep in mind, although I'm not writing it down, k is technically an integer because n itself is an integer. So there's no other way for k to be something else. And so we would like to show that 8 divides n squared minus 1. So let's consider the quantity n squared minus 1, which can be written as 4k plus 1 to the power of 2 minus 1. This is by direct substitution. And by distributing the power, or foiling, I end up with the solution 16k squared plus 8k. And the special thing here is 8 can be factored, and the resulting term is 2k squared plus k. But remember, k was an integer, so therefore 2k squared plus k is also going to be an integer. This is highly important because if we know that a times an integer is equal to n squared minus 1, this will imply that 8 divides n squared minus 1. And that's exactly what we wanted to show in this problem.